Now let's go for problem number 6. Again, this is going to be a 16-mark problem. It is based on isometric drawing. Let me zoom in and let me see what has been given in the question. Figure shows the orthographic views of an object by first angle projection. Okay. Draw its isometric view. That means you have to make the isometric drawing with respect to the true dimensions. And give all the dimensions. Well, I am not going to give the dimensions at the end. You guys can do that. What I am really interested in is creating the isometric view, and I'll give you the step-by-step approach. First of all, take a careful look at this. What is the length? Means from here to this point. Sir, this is going to be 190. How? Sir, this is 45. The radius? Yes. Then the distance between these two centers is 100. So total is 145 now. And then this is also 45, sir. You can clearly see that this is the center line. So 45 and 45, right? That is how it will make 90. So 45 plus 100 plus 45, that is the total length. That is 190. Secondly, we have been given the height. This height is 15 and this is 30. So there are basically, there are going to be two different heights which you have to fit in your isometric drawing. All of this can be accomplished. The most important thing that you must note is this square hole over here. Can you see this? Dashed lines. When do we use dashed lines? Sir, when there is a hidden feature. So something is hidden. There is an edge which is hidden, and which basically indicates that there is this square hole over here. Okay, and so is this one. That's 30 by 30 square. This is a 40 by 40 square. Now, how all of this can be implemented? That is going to be our agenda, and this is going to take around 20 to 30 minutes. I want all of you to increase the speed of the video from the player settings. Please go ahead and do that. From left to the right end, 190. The width happens to be, sir, this is 45. That's 45. The width is 90. 190 by 90. Right? That is how you are going to approach. And let me show you, my approach is going to be absolutely stepwise. Okay? Because if I start creating the entire drawing over here, so there is going to be a lot of construction. You guys may get confused. So I am going to give you this timeline approach wherein I'll do some construction, I'll do some work, and then copy it again. Okay, again I'll do modifications, copy it again do modifications, and in this manner we'll finish the entire drawing. Make sure whenever you are making an isometric drawing, use a very light pencil. Hold it very lightly. 3H pencil to be precise. Shall we proceed? Here we go. Let me erase all of these things. As decided, 190 is the length, width is 90. The height has to be given in two stages. Okay. There is a platform which has a height of 15. Then there is another which has a height of 30. Take a look. It's a very interesting case. And whenever you make any isometric drawing, please make sure that you have got these isometric axes ready. Okay. Whenever I say that draw a line, either that line will be parallel to this isometric axis or this one or this vertical. Okay. Left, right, top, bottom. That's the only way, or these are the only options of making or creating lines. Let me start. Line command. And by the way, all of this can be implemented manually on your drawing sheet. I'm doing the same on a virtual screen right now. So don't you worry. Click anywhere on the screen. Now move at an angle of 30 degrees. Okay. You can see this line that I have, this green color line is absolutely parallel to this over here. Right. 190. Done. Please switch on this polar tracking. Let me show this to you once again. There is this polar tracking. Inside the option, if you see, I've set it at an angle of 30, 60, 90, 120. Okay. So basically, I will be working at angle of 30, 150 degrees and so on. So, okay, don't worry. In order to switch it on, what you need to do is, if I click on it, nothing will happen. If I click on it again, it gets activated. Blue color. All right. So this is 190. You need to make another line. This is the width. How much is the width? It's 90. Then over here, this way, again 190. This way, automatically it will be closing out. Control X, Control V. Let me make the drawing here. Now, how shall we proceed? Again, if you watch, I think it would be better if we can create the top view first, and then gradually we'll be giving the heights. Okay. So there are two profiles in the top view. One is this circular profile, and while the other profile is this sort of U-shaped and then the semicircle over here, right? So how to approach? I think the best way forward is to create this circle first and then this semicircle, and then we'll see what happens. Okay. To make this circle, you first of all need to locate this center. Where is this center? Sir, in fact, both the centers, from the left, the distance is 45. You can see this. And here also this center is at a distance of 45 from the rightmost part or rightmost face of this object. So 45 from either ends. What you can do is you can locate the center of this particular edge over here. This is where the center is. Okay, half of 90. 1 sec. Locate the center. And then move along this direction. How much? Sir, this is 45. Enter. Done? Okay, sir. Now, this distance also has to be 45. Again, locate the center. And in this direction, 45 and enter. Again, you've got the centers. What you now need to do is, with the help of this center, you need to create a circle. Now, this is the orthographic projection and you can clearly see the circle. It's an actual circle. But as far as the isometric view of a circle is concerned, it would look like an ellipse. What is the radius it is having? Sir, it is having a radius of 45. Okay, agreed? Yes. And what about this semicircle? This is also having a radius of 45. So what I'll do is click, copy, paste point. Okay. So what I've done is basically, this is still the center. 45 front, 45 at the back, 45 to the right, 45 to the left. This way. This way. Okay. This way. 45. Let me extend this. EX, double enter. Select this automatically. Yes. 45, 45, 45, 45. So we can now successfully go ahead and create our circle. Let me select them. And I have to also make a line again. Use the copy command. Use this as the center. Click. Done. In fact, some of the universities have already started this entire curriculum of teaching engineering drawing with the help of software. And the widely used, or I mean, mostly recommended software is AutoCAD. Okay, I'm using the AutoCAD 2018 version. So if you guys want to make this on this virtual environment, start learning AutoCAD. Okay. Now, this is the larger diagonal. This is the smaller diagonal. I use this approach, right? And take a look at the smaller diagonal. Corner and the opposite end. This is the end opposite, right? This is the opposite side and its center. Enter. Again, corner and the opposite sides center. Click. Again, corner, opposite sides, center. Again, corner, opposite sides, center. Done. Now you can create a circle. What are the centers? Sir, this is the center. That's the center. These two are also the centers. Arc, center, and start with this as the center. This much as the radius, rotating the anti-clockwise sense. And there you go. Again, arc, center. Take this as the center. This much as the radius. A bigger arc, bigger radii. There you go. This is how easy it is. Again, arc, center, center, radius. All of these things can be implemented manually on a drawing sheet. I'm doing this on a computer screen, don't worry. But the world is going to change very, very soon. I can see that. And people are going to move from manual drafting to computer aided drafting in the next 5 years. So better to keep an edge. Okay. All right. So that's done, sir. What else? What about this semicircle? Okay. Can be made. First of all, let me make a line passing through this point. Absolutely along this line. Okay. Let me do that. Use the copy command. Center. Click. And okay. Do the same. Close it down. Wonderful. You need to apply the same process. Again, if you even if you apply the same process, I mean the construction will remain same. You are going to eventually end up. Let me just show this to you. you are going to end up, because here also you need to apply the same construction techniques. Okay, no difference whatsoever. I'll simply copy this entire construction. I'll place it over here, right? So what we need only this much portion. If you watch carefully, we need the circular, semicircular portion. So I'm going to chip it off. That's what I need. Now let me copy this. Let's move ahead in the timeline. This is what we've done, and I am going to erase some construction so that you guys can visualize it properly. Delete, 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 and okay. Now I mean, what are the boundaries? So you don't have to extend this line, you don't want to have this line either. So what I'll do is I'm going to chip it off again. Make sure that you create this drawing with the help of 3H pencil, so that all the work is very light. Okay, let me copy this again, and now let me start with the modification process. Okay, the first thing that you need to observe is that this circular profile over here is having a height of 30, and then there is this profile, this sort of semicircle here, and then these straight lines. This will be lifted by a height of 15. So this is 15 and that's 30. So let me do this. So through all of these points, you need to keep your mini drafter absolutely vertical, okay, or in the horizontal vertical position, and then you need to take any point and then give it a height of 30, 30, and enter. Can you do this? Easy. Okay, let me copy this. Paste. You guys don't have to make these lines. I'm going to make these lines because points are not visible on the screen. Okay, how high? All of these points are 30 millimeter, or are at a height of 30 millimeters from this circumference, right? And then with the help of a pencil, you can join all of these points in proper sequence in order to have a smooth curve, which eventually is going to look something like this. Let me copy paste. Here we go. Wonderful. In the same fashion, this portion also has to be given a height of 15 millimeters. Let us do that. And one more thing. If you watch, let me go back. Here also we'll see a circle. Only some portion of the circle will be visible to us, right? So we need to keep that in mind as well. Just a sec. So take the midpoint of all of these lines, right? Just a sec. Let me explain. Copy. Center. Here is the center. Okay. So far so good. All right. This profile over here has to be given a height of 15. So we can do that very easily. What we basically need to do is, I think it would be better if I can make a line over here. This is at a height of 15. 1 5. Enter. Done. Okay. Select. I can do the selection process. If you're doing it on AutoCAD, follow my steps. If you're not on AutoCAD, what you can do is keep on making points. Here. I mean, at regular intervals, approximately. And then join all of these points in proper sequence. You are going to have the same profile lifted by a height of 15. Okay. This is how you do it. And now let me repeat the process. Copy, base point, paste. Now we copy this again, Control C, Control V. Okay. Now take a look. Delete, 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 delete. That's not needed. Let me. Hmm, This is not needed either. This isn't needed. Trim. Okay. Select. Done. Done. Looking good. I'm chipping off the portions basically, nothing else. This is not needed. Not needed. Not needed. Make sure your initial drawing is very, very light. Kept very, very light. Shift is the tangent approach. Okay, looking good. Let me chip off this portion also. We are basically fine tuning our drawing, nothing else. Okay, anything else? I think we should need to remove this portion also. Looking good now. Anything else? This. Let me copy this. Okay, now it's looking good now. And let me chip off this portion also very slightly. Looking good now. All the edges have been smoothened out. Okay. Now the only thing left are these circular, not circular, but square profiles. So you first of all need to make them, but how? How do you make the isometric view of a square, which here you can clearly see it is at a certain angle. The square is not horizontal, right? It has been kept at a certain angle, let's say 45 degrees. Okay, how do you make this? So you can say, sir, we already have the centers and we just need to know what this distance is. How will you calculate this distance? Sir, we can use trigonometry. This angle over here as 45 degrees. So this is going to be 40 cos 45. That's 40 sine 45. But your engineering graphics teacher may argue that this is not the right way. He may put forward an argument that you are doing or you're taking the help of mathematics. Don't do that. What you can do is basically make the orthographic projection of this square 40 by 40, and then from there the dimensions, the two dimensions can be taken and fitted in this isometric view. Let me show this to you. What I'll do now is make two squares, one 40 by 40, other is 30 by 30. Let's do it. Okay, again we need to make a copy. Control C and Control V. Okay. If you watch, you sort of know this. This is 45 from the left, 45 from the right. Again, okay, you already have this point, right? In the construction, this is the point you have. So you guys may get into trouble if you don't do your work, I mean, with a lighter pencil. Okay, so make sure that you follow all the instructions carefully. So 45 from over here and 45 from over here. Let me demonstrate. 45 from this side, enter, and again 45 from this side. Where is that point? Right, and this is where the exact location where the center of that square is going to be. So first of all, create two squares, orthographic projections. Let me do that line command And over here you can just make a rough drawing at the rate 45 angle. No, why at the rate of 30? First of all, angle 45, again at the rate 30, angle minus 45, again at the rate 30, angle minus 135, and join finally. Now you need to make another square here. At the rate 40, angle 45, at the rate 40, angle minus 45, at the rate 40, angle minus 135. Done. All right, please do the construction in this fashion. Okay, good to go. Now what's up? Follow the steps. This is the orthographic projection of the squares. You need to create their isometric projections with this particular point as the center. How do you implement this? What we can do is make sure if you're drawing this manually, make sure you have a compass. Okay, keep one leg of your compass over here, other leg over here, with this much as the radius. Now what we'll do is, there is this 30 mm square over here. Fit it. Done sir. Do the same over here as well. Again, use this one leg over here, other leg over here, with this much as the radius. Now let me move this. This is the center. Here we go. So where are we going with this? We were supposed to create two squares. One was 40 by 40 while the other was 30 by 30. What are you doing, sir? Why are you making these circles? Well, these are my reference. Let me show this to you very quickly. So trim, extend, double enter, extend, trim, extend, double enter, extend, double enter, done, double enter, done. Now let me rotate these lines. You can create your own lines also, no problem. From here also along this direction. Okay, along this direction I'm talking about. Okay, what I'll do is, let me use a smarter approach. Control C, Control V, and let me rotate this arrow. Okay, base point, let me select the center as the base point, 120 degrees, right? Again, now move with respect to the center, bring it to the center, and done. Right now, when this is done, remove the circle, or you can keep the circle also. It is your choice, no problem. Need to repeat the same. Let me copy this with respect to the center. This will go beyond the circle, I mean, as expected. Okay, use the trim command again, chip off these portions, and then remove the circle also. Now what's up? Now you can simply join all of these corner points. We have created the isometric view of these squares successfully now. Okay, and now let me copy, Control C, Control V. Now what you can do is, let me remove the inside portion. Again, if you watch these two square profiles, they're holes, right? And here the depth is 30 and here the depth is 15. So they have to be taken into account. I don't know whether the bottom portion is going to be visible or not, but let's check it out. Why not? So all of these corner points will go down by a distance of 30, and here all of them will go down by a distance of 15. True? Yes, sir. Let me do that. Click at the rate. This is going to go down by a distance of 30. Enter. Now let me copy this. I mean, you don't have to make a line. You simply need to mark points 30 mm below through all of these corners. Okay, now let me make a copy. No, nothing is going to happen, students. Use the line command again. These are the 2 points. Then there is this point. The bottom edge won't be visible to you. Okay, the bottom edge won't be visible to you. If you don't believe me, let me show you through this sketch. Until and unless, this is the perfect isometric, right? You don't, I mean, this is the 3D environment. This is the 2D environment. This is the 3D environment. Okay. This portion is not visible. This wall is visible. Some portion of the wall is visible. And let me show this to you once again. Here it will be visible. Here it is not going to be visible. So you don't have to worry. I think I would even suggest you to delete. Done. This portion is done. What about this portion? You can make a check, very quick check. So we can do this 15 mm below. Copy. Now, sir, some portion is going to be visible. Now you can make an argument with me. Okay, let me join all of the bottom 4 corners. Where is that point? Here it is. Here it is. And here it is. This portion is going to be visible. And as you can see, it's here is the validation, right? And we are done. We are done. Right? It's done. This is how the final drawing is going to look like. I hope that this problem has helped you understand the concept of isometric drawings. All of this has been done with the help of true scale. That means 1:1. No changes in length whatsoever. Everything has been maintained properly. Right? This took around 27 minutes and 30 seconds. Okay. Thank you.